And now we will see case number 3. Now previously what we have seen, this A line of action of ft passes below the fulcrum. Now in the third case, when the line of action of the tangential braking force ft passes above the fulcrum. So now over if we see over here, this fulcrum is over here, line of action of ft is above this fulcrum by distance of a. Now by taking moment about O for the clockwise rotation, again two cases, clockwise and anti-clockwise. So what will be the effect of this ft? Rn into x. As I said, the line of action of this will be in this direction, and because of that this will be rotated in this. So this particular will assist ft moment, because of ft will assist the moment because of the force p, and that's why we can say Rn into x is equal to p into L multiplied by ft into a is equal to pl plus mu into Rn into a. Rn, again taking this value to this side, Rn is equal to x minus mu a is equal to pl. Rn is equal to pl minus divided by x minus mu a, and breaking torque Tb is equal to mu into Rn into R is equal to mu into p into L multiplied by R divided by x minus mu a. Now for case number 3, for the clockwise rotation, and for case number 2 for the anti-clockwise rotation, the equations are same. Okay, so these two equations are same. And similarly for the anti-clockwise rotation, if you see, again taking the moment Rn plus x, now if this is anti-clockwise, it will ft will act in this direction, and because of that this will have the effect that this lever will be going in the upward direction because of this moment, and that's why we can say moment because of ft is adding to the moment because of Rn, and that's why Rn plus x plus ft into a is equal to pl, taking equilibrium for this particular system. And then Rn x plus mu into Rna is equal to pl. Rn is equal to pl divided by x plus mu a, and breaking torque Tb is equal to mu into Rn R multiplied by R is equal to mu into P into L into R divided by x plus mu a. Now this particular formula, that is in the for the case number 3, in the for the rotation in the anti-clockwise direction of the drum, is same as the relation of expression for the TB for the case number 2, when the drum is rotating in the clockwise direction, right? So very important or cases we can generalize from this. In case number 2, when the brake rotates in anti-clockwise direction, and in case number 3, when the brake rotates in the clockwise direction, the equation is same, and is Rn multiplied by x is equal to pl plus mu into Rn into a. You can see for the case number 3, when it rotates in the clockwise direction, this Rn into x is equal to P into L plus mu into Rn into a. Right? Rn into x is equal to P into L plus mu into Rn plus a. From this fractional force mu into Rna add to the moment of force PL. From this what we came to know, that is this is the force which we are applying to which we are exerting to apply the brake, P into L. This is a moment which we are applying to apply the brake, or this P is the force which we are applying on the brake pedal, right? And this mu into Rna, this is assisting this force P, or this is adding to the moment of force P into L, right? So because of that, what we can say, in other words, frictional force has to apply the brake. Because of that, this such type of brake is said to be self-energizing brakes. Means a little push on the pedal will help you or will assist you to apply the brake, because this mu into Rn into A, or uh, frictional force is assisting this particular braking force, and that's why this type of brakes are called as a self-energizing brakes, and it will assist the user to apply the brake, or little efforts will be needed for applying the brake, right? Right. So again, we will see over here, we will rewrite this equation: Rn into x is equal to PL plus mu into Rn into A. Rn into x is equal to PL P into L plus mu into Rn plus Rn, sorry, what happened? Okay, we will rewrite, just a minute. Okay, so now what I am doing, I have rewritten this equation, that is Rn into x is equal to PL plus mu into Rn A. So if I shift this particular term, that is Rn into x minus mu into A is equal to P into L, right? So I shifted this particular term over here and taking Rn common. So what I can say, so if I say, if x is less than equals to mu A, then P will be negative, right? So if value of x is less than mu A, so as mu is a negative term, and if it is less than this, the entire term comes to be, this term comes to be negative, and because of this Rn will be negative, and that's why we can say P will be negative. Now P is what? Force, braking force exerted. Now when I say braking force exerted and it will be negative, it means that this type of brake will be self-locking brake, or self-locking brakes. Means is we will not need to apply any braking any force on the braking pedal. Whenever the machine will start, it will automatically apply the brake, and this type of arrangement is called as a self-locking brake. Or I can say, if x is less than equals to mu into A, right? What is A over here? A is nothing but distance of the distance between the line of action of tangential force Ft and the fulcrum. So this will decide, if x is less than equals to mu A, then this brake we can call as a self-locking brake, right? And for generally this condition is not desirable, because brakes, if brakes are self-locking, our machine will not move, or our vehicle will not move. So brake should not be a self-locking, and in that case, to avoid the brakes to be self-locking, x value of x should be always greater than mu A. Value of x should be always greater than mu A, right? So this condition we have to take into consideration. So brake may be a self-energizing, but it should not be a self-locking. Then we will consider if AB is the projected area of block coming in contact with wheel, right? Then pressure exerted on shoe is equal to what? This PB is equal to Rn, this is the force, right, which is exerted on this, divided by the cross sectional area, that is AB. So I can write down over here, that is pressure PB exerted on the shoes is equal to Rn divided by AB. Now this AB is nothing but width of the shoe multiplied by projected length. Projected length of shoe. Projected length means this particular length, right? So this will be equal to width of the shoe will be W multiplied by 2 into R into sine theta. How this 2 into R into sine theta comes? I can show you over here. Now as this is the projected length, if I consider this particular triangle, so I write down this triangle over here. This is R, this angle is theta, as total angle is 2 theta, this angle I can say theta, okay, and this is the x, length x, which we need to find out. Now as I know, sine theta is equal to opposite x upon hypotenuse is r, so I can say x is equal to r sine theta, and for this particular, this is x, and for up to this is 2x. That's why I can say total length is equal to 2x, that is 2 into r sine theta. That is what we have taken. AB is equal to W into 2r sine theta, right? So this is nothing but PB is equal to Rn divided by AB, where AB is equal to W into 2r sine theta. This PB is the bearing pressure on the shoes. As we can see over here, whatever the arrangement is in there, we are having a shoes over here, and this shoes is being pressed against the wheel because of when we apply the downward force P, and because of that what will happen, there will be the excessive load on the shaft of the wheel, okay, because as it is pushed in the downward direction, and because of this braking action there are the chances of bending, of wheel shaft, right? So that is, we can say, limitation of single block shoes, and that's why there is a improvement in the design, and then there is a use of double shoe, or the we can say double block or double block shoe brakes. So in this both from the both directions forces are applied, and because of that this bending of the wheel shaft is avoided.